Good morning, all of you. Today we are going to discuss about the assembler directives. And in the directives category, we are going to discuss about defined and reserved directive, which are extensively used in assembly programming language. Now, what is defined directive? Defined directive is used to define a variable of a certain type and to reserve the storage space of that particular type in the memory. We extensively use defined directive to define words, to define bytes, to define code words, and to define 10 bytes. So the directive which is being used for defining the byte is db. db means it will allocate 1 byte of memory to the whatever variable you have defined. It means it will allocate 1 byte of memory space for that particular variable. Now there is another variant of the db is dw, which stands for defined words, and it allocates 2 byte or 16 bits. Then there is another one which is the double word. dd is the defined double word. It allocates 32 bits. Then dq is the chord word, and it allocates the 64 bits of memory. And dt is the defined 10 bytes, and it is going to allocate 80 bits in the memory. So these are all the defined directives which are being used in assembly programming language. Now if we see an example of defined directives, we can see here the choice db, and in the quotes we are giving y. It means your choice value is yes. So it is going to allocate 8 bits or 1 byte for this particular choice variable. Understand? And here we have already initialized this choice. So generally when we use initialization, we use defined directives. Now there is another variable which is the number, and we have defined that number with the size word. So it is going to allocate 16 bit of memory for the number. 1, 2, 3, 4, 5 is being initialized for the number variable. Now there is another one, negative number, and we have used defined word. It means we are going to allocate 2 bytes of memory for negative number, and the value for the negative number which is being initialized is -1, 2, 3, 4, 5. Now each byte of character is stored as an ASCII value in hexadecimal. You already know that in assembly your number will going to get stored with their ASCII equivalent values, and each decimal value will automatically converted into their 16-bit equivalent and stored into the hexadecimal number. Negative numbers are converted into the 2's complement representation. This is the way assembly program works. Now, if there is uninitialized data, so which kind of directive you need to use? There is one more directive which you can use for uninitialized data. In the previous slide, whatever we have seen is for the initialized data, where we have already initialized the data with certain value. If we have not initialized the data, then we can't use the dw, db or dq as the directive. So in that case, we need to use another directive which is called as a reserve directive. The reserve directive are used for reserving space for uninitialized data. The reserve directive take a single operand that specifies the number of unit of space to be reserved. Each defined directive has a related reserve directive. Now you can see in this example, if we want to reserve the byte for a particular variable, then we need to use RESB. If we want to reserve the 2 bytes, or we can say the 16 bit for a variable, then we need to use RESW, which is reserve word. If we want to allocate 32 bit for a variable, then we need to use REST, which is reserve double word. If you want to allocate 64 bits, then we need to use RESQ, which is reserve chord word. And if we want to allocate 10 bytes, or we can say 80 bits, then we need to use REST. Now in the next slide, we are going to see an example. Now for example here, this is a buffer variable and the reserve byte are 64. So it means it is going to allocate 64 bytes for that particular variable. Then word variable will have the size of what? One word. It means it is going to allocate 16 bit for this particular word variable. Now there is an example of real array. It is going to allocate 64 bits for each individual of this, like 10 real arrays will be allocated with the memory of 10 multiplied by 64. So this much memory will be allocated using this particular reserve directive. Thank you.